Judging by the complete ignorance of your statement.
Hello, baby.
Here's what you're referring to. The sandhills of Nebraska. Okay. Now, evolutionists would have you believe that this sand was deposited here by alien mechanisms.
Did you say alien-y mechanisms?
You have made me very angry indeed.
I believe the word you're searching for is aeolian. That's aeolian.
In other words, by the wind over vast amounts of time. Okay? That's not possible. Okay? First off, they're 330 feet on the east side and 3,600 feet on the west. Now this lines up with the effects of the Milwaukeean flood, because as the plates of the earth moved away from the mid-Atlantic ridges, they met greater and greater resistance, which rose the mountains. And that's why these sand hills are higher in the west than in the east, you see.
That's fascinating, Neff. Here's an alternative idea. The dunes are thicker in the west because they're nearer the source of the sediment. It blew from the northwest, Neff. Now, I could also cite, the evidence of the mineralogy, the sand grains, the angle of repose of the dunes, but I'm going to save that for the next section, so I'll just leave my answer at that.
Because I know evolutionists don't study much. Here's another one. Even evolutionist scientists agree with this one, okay? This sand began here and was deposited here. It is the Navajo and Coconino sandstone deposits, okay? Evolutionist scientists agree. This sand is believed to have originated in the New York State area and was deposited here in the southwestern United States. That's a very great distance. That's well over 1,000 miles. That's perhaps 2,000 miles. Okay. I don't know how far. But now let me fill you in on a little tricky thing here. Think about this. Wind cannot deposit sand from here to here. It's never going to happen. The sand has weight. It will fall to the ground before it makes it here. Not even over billions of years would you get sand in massive amounts from here. Millions of tons of sand from here to here because of wind.
Well, my little ginger snap, I bet you've been reading this article right here. Before I explain the consensus point of view, I'd like to take a little time pointing out flaws in the conclusions of this article and, by extension, you. Since it's simpler to deal with one formation, I'm going to primarily focus here on the Navajo sandstone. You're quite right in pointing out that there's a lot of sand out there. It's about 40,000 cubic kilometers. It's mostly quartz sand. There are a few minor constituents, but mostly it's a nice, clean quartz sand. Now, Neff, you're arguing that wind could not possibly have transported the sediment from the Adirondacks to Utah, where a lot of the sandstone is at. So, I'll get back to that in a minute, but first I want to focus on a problem I see with your model. It's that the rocks that the sand is derived from are very tough granites. I mean, they're really hard rocks. So you're proposing that within a relatively short amount of time, let's say days, 40,000 cubic kilometers of granite was eroded by the flood and then transported as a unit to Utah without being dispersed by the floodwaters and laid down as the Navajo sandstone. Do you see a problem there? Here's the second problem. I say granite has three major constituents. Quartz, obviously, but also a great deal of feldspar and also mica. So when the granite was eroded and carried by whatever means to Utah, how is it that only the quartz ended up being deposited as the Navajo sandstone? What happened to all that feldspar and mica? A third problem I see, the Navajo sandstone's not very fossiliferous. There are some fossils, bits and pieces of mammal-like reptiles, maybe some early dinosaurs, few tracks of reptiles, tracks of what are presumed to be scorpions or spiders in the sand, some bioturbation, worm burrows and that sort of thing. Where are the marine fossils? There aren't any. Okay, why do we think the Navajo sandstone is an aeolian or desert deposit? First of all, it's the crossbeds. They're typical of sand dunes. Sure, there are other environments, aqueous environments, that have crossbeds, but the crossbeds are distinctly different, and it has to do mostly with the angle of repose. In a dry environment, in an aeolian environment, the angle of repose can be much steeper, up into the 30s. For crossbeds in an aqueous environment, like in a delta, it's typically down around 20 to 25 degrees at most. Secondarily, it has to do with the mineralogy. A typical desert sand is usually a relatively clean quartz. There's not a lot of other constituents. And here are two samples from the Navajo sandstone. Sometimes it's red, sometimes it's white. The pure sand is white. The red staining is from iron oxide. Also, the grains tend to be very well rounded and very well sorted. That is, they're all about the same size. Now, about the problem you have with transport of the sediment, let's look at the paleogeography at the time of formation of the Navajo sandstone. The Navajo sandstone was here, and the source of the sediment was here. Now, Neff, you've argued that winds could not have transported the sediment across the country and deposited it as the Navajo sandstone. Interesting enough, I would tend to agree, but there is something about the paleogeography that you have overlooked. At that time, to the east were mountains, to the north highlands, and to the south mountains. Therefore, drainage across the continent would have been to the west. So, the drainage system itself would have been a perfect sorting mechanism for the quartz, the feldspar, and the mica, eventually depositing a great deal of the quartz much to the west of its source area, much as the Mississippi deposits sediment now from Minnesota. Sand ripples in the Navajo indicate that throughout the history of the Navajo sandstone deposition, prevailing winds were mostly from the north-northeast. And so, over time, it is reasonable to assume that the quartz sand could have been transported from its aqueous deposition point to its deposition in the deserts of the Navajo. Neff, I do believe that's a more reasonable explanation than your massive erosion over a few days of an enormous volume of granite. Alright, sweet cheeks, like I say, if you're confused by anything else, give me a buzz.
Okay.
Moron.